It's become less due to the loss, due to the damage, the crack, due to the corrosion, the area become thinner and maybe broken off, it's totally lost. So as the stress become high, when the stress is high, too high, it become higher than the material strength, which is in the unit of stress. When it's higher than material strength, then the part will fail. The part start to crack or the part will rupture. So repair, we need to repair. We need to ensure whatever strength loss we recover, we restore. Okay, so that's why the terminology definition of repair is restore. Restore the structure strength. So how to restore? How to restore? We need to recover the loss. There's a loss in cross section, and there's a loss in cross section. So we recover by putting additional plate. That plate will recover the loss of the area. So recover loss area, or in other words, we say restore. That's why in this study, we will focus more on try to determine what has been lost and what has been restored, or how to restore it. What has been lost is basically we're looking at the load. How much load has been lost? So how to determine that? First, you need to see the structure construction. That's why some part of this study, we need to understand the structure construction. We need to understand the structure construction because we need to understand how the structure carry the load. For this situation, you can see section of skin. We have bulkhead here, bulkhead frame here. We have stringers here. So you can see the massive structure. We can see how critical is structure depending on the construction. You can see here the bulkhead here, the frame here is heavily constructed. We have angle cap here, angle cap at the bottom here, and everything attached to the fuselage skin. So this is heavily constructed because this carry a lot of load. They carry shear load. They also reduce the column length of the fuselage. So this area is heavily loaded. The structure is basically carry the load circumferential. For this stringer, they carry a load longitudinally along this aircraft fuselage horizontal axis. So I look at this. Imagine if this frame is damaged, so you have to restore the area. So either you cut off, put a new plate, and the load transfer across the plate using a doubler, or you put the doubler over the damage. So those are the only typical repair. If you go to a aircraft structure repair manual, you cannot run away from saying repair by splice, cutting out the section, putting new section, and transfer the load using a doubler, or splice doubler, or if you got the small damage, remove the damage and they restore the strength by putting a doubler. So they transfer the load across the doubler, share it with the current plate, and the doubler will add the additional area in order for the structure to get a lower stress. So this is typical concept repair. So concept repair, our concept is looking at the restoring the aircraft structure strength. Type damage I have been through here with you earlier. Type damage. Okay, if you got report, if you have report that you have the structure is damaged, first thing you need to do is inspection. You have to verify the damage. You have to ensure the structure is damage is. You need to understand whether the damage is repairable, non-repairable. Some definitely we cannot enter the area, we cannot touch the area. If the area damaged, you end up to replace the parts. Some may require that. That's why as you receive a report, the structure is damaged, the first thing you need to do is to get the indication, to get the part number. What are the damaged part? What are the part number? Where they are? And you have to search the structure repair manual to look for the characteristic of the part. What is the part for? What is the part used for? How the load is transferred to the part? What are the rivets used? What are the type of material of the part? The first thing you need to do. Then the next thing is you do inspect the structure. You have to do the structure inspection to determine the extent of the damage. Okay, you have to do structure inspection. So first thing you need to do in doing the structure inspection, if it's a major damage, then you have to bring the aircraft to the hangar. You have to put the aircraft into tracer and you have to show it. You have to level, put the jack, level it and show it, show and throttling. Show and throttling, why we use that? Because we want to make sure the aircraft is in the relaxed mode. It is in the condition for everything as the stress around the fuselage at zero. Everything are supported. It's natural. So the aircraft structure is not stressed. Nothing is loaded. The landing gear off and on, you jack, the wing been tracer, the fuselage been shoring, so everything are supported. So there's no part of the structure being under stress. And then the first thing, the second thing after you do hangage and storage, shoring and throttling, you need to do alignment and symmetry check. You need to see whether the aircraft still within the acceptable dimension. Alignment is to ensure to determine whether there is any distortion on the aircraft. Similarly, alignment and symmetry check. The objective of this check is to ensure whether there is any distortion on the aircraft. Distortion means there are damage. Remember, I said earlier, when I go through the stress and strain curve, in aircraft structure design, we only accept, we do not accept permanent deformation. If we do alignment symmetry check, we found there are some distortion, means that there are already permanent deformation, which are not allowed. That's why we do use alignment and symmetry check. So this is some example how we tracer the aircraft, how we show the aircraft. Through my experience working aircraft, there's some time we are not able to properly show and tracer it. As we inspect the aircraft, we open up a few panel, you can see the aircraft start to sag or something popping out. So mean the aircraft is under stress, it's not properly shown. So this is alignment symmetry check. Alignment symmetry check done. For symmetry check, we drop point on the floor, we measure, we check there are any differences between the measurement. For example, we measured from the nose to the wingtip, left and right, port and starboard. If we should be able to maintain within certain tolerance, if more than the tolerance, means the wing has been distorted. So that is how we do symmetry. For alignment, we check points, and then we drop point to the visual plane, and we see whether, for example, we drop point from the wingtip, to the virtual point, and you can see one wingtip is higher than the other, mean there is some permanent deformation. The wing has been distorted. So those are symmetry check. And then we inspect the damage in detail. We may do visual, we do NDT, eddy current, ultrasonic, depth penetrant, X-ray, gamma ray. So those are type of NDT. So NDT is used to determine the extent of damage. How long is the crack? How far the crack goes? How deep is the corrosion? So how deep is the gouge? How big is the size of the puncture? So those are the detailed inspection you need to do. And if something is not visible, for example the crack, you can't easily visible the crack. You can see the crack, but you don't see the tips of the crack. That's why you have to do this NDT, non-destructive testing inspection. Before you do the damage inspection, you may remove all the unwanted material to clean the surface, but be careful not be excessively doing it. You may close up the crack. Follow the structure repair manual how to do the cleaning. Cut out all the broken, bent, heated, damage. Okay, remove all the loose rivets. If you want of indication there is a damage, you lost the rivet heads. When you lost the rivet heads, mean the area has gone through excessive loading, which end up in shearing of the rivets into half, and the head has been popped out. So, okay, damage. There is also we need to look at the secondary damage. Secondary damage is as you see, for example, when you had a bird strike on the radome. You can see visibly the radome punctured, the bird may goes inside the radome. So that, but however, the secondary damage. Secondary damage is all the part associated, all the component associated to that radome. Maybe the mounting, the frame. So for in doing our inspection, we also need to consider those secondary damage. They call it secondary damage. Happen to other part of the structure. Okay, alignment and symmetry. So you can see there's a point here. Measurement, you measure the point. What are the points? Maximum symmetry difference. So if more than this, and then you have to be concerned because the structure has been damaged. And normally you have to refer the structure repair manual. In this case, I'm showing you 737-300 structure repair manual. So everything that you do from the inception, from the aircraft, from the day the aircraft comes to your hangar to the day you release the aircraft, after you completely repair them, you have to follow this structure repair manual. This is the acceptable data from the OEM. Damage assessment. Damage assessment, it can be the term of damage. Is any type of permanent deformation or alteration to cross section of structure. Permanent deformation or alteration to any cross section of the structure. Again, we use the word cross section. Why? Because if you alter all the cross section permanently deformed, possibly the cross section area become less. As I said again, as the cross-sectional area become less, you have similar forces acting on it, your stress will be increased. And we do not want the stress increase to as high as the material strength. If it is higher than material strength, then the structure will fail. Okay. The damage can be caused by mechanical, chemical, electrochemical action, thermal action, or cycling. So mechanical, obviously, like we have explained earlier, the truck hitting the aircraft, or someone maybe step on some part of the aircraft. Chemical or electrochemical reaction could be corrosion. So those are type of damage, that type of item or action which can cause the damage to the aircraft structure. In doing the damage inspection and damage repair, you need to consider first, very important, some people miss it, aerodynamic smoothness, because there is a requirement now. Most aircraft having certified to RVSM, reduce vertical separation minima, and the aircraft is, when the aircraft configured into this, they're able to fly within 1,000 meter between each other. Yeah. And the structure, strength, durability, and reliability. So those are something you need to consider. So investigation on aerodynamic smoothness, the aircraft manual will give you the aerodynamic critical area or aerodynamic smoothness tolerance in the manual. So the manual will give you what is the limitation on the aerodynamic smoothness. Sorry, it's not 1,000 meter, 1,000 feet. So RVSM will be allow the aircraft to fly within 1,000 feet from each other. So for having the aircraft must be in good condition, especially in doing the the reading, the pitot static reading should be very accurate for you to get the accurate altitude, distance, speed, and the aircraft configured to RVSM, and RVSM aircraft is very sensitive to this aerodynamic smoothness. Then we look at the damage classification. There are repairable, non-repairable, allowable. If allowable, main category A, no repair, no inspection. So very minor damage, does not affect the aircraft. Not repair but inspected, there is still able to have the strength, and that you don't lose the strength so much. You don't need to repair, but you monitor to ensure the damage is not growing. And category C, you repair and you monitor by inspection. So this is more critical. Occur on primary structure, and this is at the critical structure. So we have repairable damage, non-repairable damage, all are in the aircraft structure repair manual. The values, the categories are given there. So in doing the structure inspection, you have to come up with a structure report. So this is one of the form I picked from the Airbus. It's very good. When I saw this form, the form has given you the cluster of information that you require later on when you're writing to OEM. The cluster of information here is aircraft data. Aircraft serial number, aircraft registration number, all detail in here. Component data, what are the name of the component, what are the component used for, what is the part number, everything in this cluster. Inspection data, what kind of inspection has been done, visual inspection, NDT, eddy current, and this cluster of inspection method, it could be more, 2 or 3 method, more than one. Detail the damage, what happened to the part, crack, punctured, bent, broken off, burn. Those are detailed damage, and they detail up to the extent of the length of the crack, the depth of the gouge. So you have to explain here the detail of the damage. Then this information, basically this form, go back to OEM, and you have to tell them what do you want. I mean, what is your requirement? Do you want them to propose a repair? Do you want them to approve your repair? You may send your repair proposal to them. Or you want them to comment the repair, so you have to state here under requirement for operation. So again, you use this form the cluster of information here. We start writing the email or memo to the OEM by writing up each cluster as a paragraph. So we have 4 or 5 paragraphs. Last paragraph is asking what is your wish from OEM. When you do the report, you have to do reporting local and global. For example, we have here, when you do the inspection, you sketch the defect and you have to show the detail of the defect in respect to the aircraft. So this view is the defect, not detail, just location of the defect with the perspective, okay, of the aircraft. Where are they in the aircraft as a whole? Those we call it global view. So global view, this is for the whoever your customer or OEM, they wanted to know where exactly the defect in respect to the aircraft. So because we know which area is critical, which area is not critical. By having the information, we are able to make decision whether the defect occurred on a critical area or non-critical area. And next is local view. Local view will be the detailed view of the defect. For this situation, we have, I believe, a skin burns. So the detail of this will be extracted out, will tell you what are the width, what are the length, how much are the depth, and what is the structure, what is the defect next to it. So those giving the detail for the engineer will able to design to cut out the area, how big are the cut, and how big is the doubler. That will be depending on the local view. Okay, so we have report, you have local view, global view. You can attach to the report. Report here translate to, you keep the form here to be kept. With the form you have the concept repair. We have the report of local view, global view, as well as we have a cover paper, a cover letter, an email or memo, which mention each of these clusters. Okay. So if you want to look at the defect, how we assess allowable or not allowable, the defect discovered, defect or damage assessment. Now we want to assess the defect or damage. So we need to look at whether allowable damage. Allowable damage means that damage is not critical, then allowed to be there. So what you need to do, just rework, refinish, and according to the SRM. No major work be done. And then if you assess the damage is beyond allowable, okay, damage beyond allowable limit, the limit given in the SRM is exceed the limit. For example, the crack only 3-inch crack allowed on the spar beam, and you have now 3.5-inch crack, and then you check for SRM if there is any repair. Is there any repair specific to the area? Any repair scheme? Any repair procedure? If you have used the repair procedure, start the repair and release the aircraft. If not, then you have to communicate the OEM, Airbus or Boeing, depending on the aircraft type. So when you're communicating with them, you have to give them the report. Here, this report, we have to give them the sketch. Or if you have proposed repair, you have to give them as well as the proposed repair together, and you ask for approval. You ask for their, either if you do not have the repair, ask them to come out with the repair. If you already have designed the repair, ask them to review, approve the repair. If you are already established with the OEM, you may hold the approval just to inform them you have designed the repair and you want to embody the repair to the aircraft. So depending on the level who you are, you can either If you know nothing with aircraft, you have no skill in doing the repair, you just ask the repair scheme direct from Airbus, plus repair approval. But you already been doing the repair for many years, you can design, propose the repair, which will be easier for you to install later on when the repair is approved. So design repair, go to OEM, Airbus or Boeing, then ask for their approval. Or last one, if you already been established as a repair design engineer by Airbus or Boeing. So just a formality to inform them that you have the defect. You have to submit all again, the defect report and everything to OEM, and just notification that you have a defect. You have designed the repair for the defect, and you just asking for just to inform or to notify them that you have done the repair. If they will review it, but if they feel there's something very wrong to the repair, they will come back and ask you to amend the repair. Report methods: fax, email, telephone, mail. Nowadays, WhatsApp also been used to report back to your customer if you're working on other people's aircraft, to report to your operator if you are operating the aircraft, and report to OEM. So this form is a fax, email, telephone, and mail. Nowadays, WhatsApp has been used quite a lot, and I think I personally, when I'm working on this area also, I nowadays using WhatsApp. We just send everything to WhatsApp, and it's very quick for them to respond. The repair, sketch, rubbing, tracing. This is method that we use in the past. Sketching, rubbing, we put mylar paper or tracing paper, we trace it, 3, 2, and 4. We take photo. Now the most common method now is photo. And the photo also, you can put text. You can explain the photo from your phone. Okay, repair design consideration. This is potential example. This is example. We have punctured skin here, so we cut off, you put a doubler. So those are common method, repair method. So this, you see this a lot in the SRM. So for this skin repair, we may have angle repair. We have also skin near the angle, near the stiffness here, cut, and you can see stiffness behind. You need to put the filler, you put a doubler, multi-layer doubler. That is for the damage tolerance analysis. I will explain it later. Okay, so this is what the repair design considerations. So for now, I believe any questions so far?
No, sir.
Okay. So I may just stop here. The rest here is something